So hi guys, today's topic is about the OS structure, the operating system structure. So first I will give to introduction about the OS structure. The operating system structure defines how its component interact. It impacts performance, security, and system flexibility. The inner parts of the operating system will interact themselves and gives us a better efficiency comparison. Next, why understanding OS structure is important. So it is important to understand the OS structure, which helps in the optimizing system performance and enhance security and stability, and it is useful to develop better software and drivers. Next, components of OS. The OS consists of kernel, user interface, system call, device drivers. The kernel is the core of OS and it's like a heart of the OS. User interface. The user interface generally called as graphics user interface, which we are using now. Next, system calls. The systems calls are the interface for the applications between the hardware and the OS. Next, the device drivers. The device drivers are refers to the hardware interactions. The types of OS structures. The common structures are like monolithic kernel, layered OS, microkernel, modular OS, hybrid OS, virtual machine OS, microkernel. Next, monolithic kernel structure. The monolithic kernel, the all OS services run in a single kernel space. Example, Linux, Unix. Its advantages are the faster execution. Its disadvantages are the hard to maintain. Monolithic kernel structures. The all services will be in a single block, which will be in the kernel in space. So the execution will be faster, but its maintenance is very tough, as all the uh, services are in a single block. Next, layered OS. The OS divided into multiple layers. Higher layers rely on lower layers. Example, Digixtras OS. Its advantages its advantages are better organizations. Its disadvantages are slower performance. All components are divided as C layers. The first layer will be hardware, and the last layer will be like user interface. The higher layers will always depend on the lower level layers in layered OS. Next, microkernel structure. The microkernel structures moves most OS functions to user space. Kernel only manages basic functions. Example, Minix, QNX. Its pros are improved system security and stability. Its cons are performance for it. The kernel will be divided as into user systems. The unwanted functionalities will be kept in the user systems, which will decrease the size of the kernel so that its name is like microkernel. So it's the security is improved and the stability is also improved, but it will affect the performance of the system. Next, modular OS structure. The modular OS structure, the kernel with loadable modules. Example, Linux with dynamically loadable modules. Pros, flexibility. Cons, complexity. The kernel will have the module which can be loadable. Example, Linux with dynamically loadable. It will be more flexible than other OS structures like microkernel. So next, the hybrid OS structure, the combination of monolithic and microkernel structures. The hybrid refers to the combination of two structures. So here I take monolithic and microkernel structures. The monolithic is a simple and very efficient OS. The microkernel, where the kernel size is very small compared to others. For example, Windows NT. So the pros are balances performance and modularity. The cons are increased complexity. Next, virtual machines OS. The OS runs as a virtualized instance. Example VMware VirtualBox. Pros isolation portability. Cons overhead due to virtualizations. So here we are creating a virtual space where it is a temporary one. We can switch the OS through this virtual box. Next, exokernel OS structure. The exokernel OS structure refers to the minimal kernel, the application controlled software hardware. Example, MIT's exokernel. The pros are high efficiency and the cons are complex application developers. The kernel utilization is minimum in the exokernel OS structure. The application can be controlled by the hardware. Next, the comparison of OS structures. So here are the comparison. You can see through the structures, performance, and securities and the flexibilities. The system calls and OS interfaces. The system calls and OS interfaces. The interfaces between the applications and the OS are called as system calls. Example: read, write, fork. The read, write, and all we can see in the file systems. So user mode versus kernel mode. The user mode, it has only limited access and it is safe. The data cannot be accessed through the memory. In kernel mode, it has full access, can execute critical operations. So it has a full access to take the data from the memory directly, and can execute critical operations. Next, process management in OS section. The process can be managed through process creation, scheduling, terminations. The structure like PCB, process control block. Next, memory management in OS system. The memory can be managed through the virtual memory, paging, segmentation. The memory allocation strategies. File system management in OS structure. The file system includes file structure, directory organization, permissions, file operations. The device management in OS structure. The device can be managed by the device drivers, input-output scheduling, buffering, caching, spooling. Security and production in OS structure. The security and the productions can be controlled by the access control authentications, encryption, secure kernels. Performance consideration in OS structure. The performance can be considered by minimizing the context switching. The memory can be utilized efficiently and the CPU can be managed. The real world examples of OS structure. The OS structure in real world can be explained through hybrid kernel where it it it's example like Windows API for applications. So I also use as Windows. So it's like an example of a hybrid kernel. Next, Windows OS structure. Windows OS structure. First, Linux OS structure. Monolithic web modules uses POSIX system calls. Linux OS structure. Linux OS structure uses Mac OS structure based on BSD Unix uses Mac microkernel. Next, Android and iOS OS structure. So it's like a mobile phone OS. Future trends: AI powered OS scheduling, cloud native OS architectures. So future trends in OS structure. So conclusion: different OS structures serves different needs. So every sectors have different ability and the needs. The trade-off between performance, security, and flexibility. It's are differentiated by their performance